Hi there, grade 7. I'm going to discuss law of exponents. But before I begin with my lecture, I'd like you to click the subscribe button for you to get notified whenever I upload new lecture videos. The exponent of a number tells us how many times it is multiplied by itself. So on the left side of each equation here, these are the exponents of the given number. And for instance, when we say x to the third power, this is like multiplying the expression x thrice by itself. So we have the right side equals x times x times x. Same with 9 to the second power, or also read as 9 squared. So 9 here is multiplied twice by itself. So we have 9 times 9, which is equal to 81. Now we have 4 to the fourth power. So the expression 4 is multiplied by itself 4 times. So we have 4 times 4 times 4 times 4. So this equals 256. Now, class, this expression x, 9, and 4 are called as the base. The other term for exponent, we call this also as power. So, what I'm going to discuss is working on the law of exponents. Law of exponents class is important, especially as we go with multiplication and division of polynomials. So let's work on the first rule, and we have this product rule. From the word product, we're multiplying two expressions of the same base, and the base here is a. So how do we work on the product of two factors having the same base? We just copy the same base and then add the exponent. So that's why we have a to the m times a to the n equals a to the m plus n. So applying this product rule, we have 2 cubed times 2 to the fourth. Since they have the same base, we'll just copy that same base too and add their exponents. So we got 2 to the third plus to the fourth. So this equals 2 to the seventh power. So 2 to the seventh power equals 128. So we have 5a squared here times 2a to the fourth. So what we're going to do is to perform multiplications on their coefficients. So this is 5 times 2, and then the same base a raised to the second plus to the fourth. So we have 10a to the sixth power. So we have three factors here. So we have also observed the rule on multiplying integers as we are multiplying their coefficients. So we have negative times positive times positive. So this will lead us to a negative value. Also, we'll multiply 2, 3, and 4. So 2 times 3 equals 6 times 4, we have 24. And then we have x to the second plus to the first plus to the first again. And then the y, we have y to the first plus to the third plus to the first. So simplifying the expression, we have negative 24 x to the fourth, y to the fifth. So this is how to apply the product rule. This time we'll proceed to the power rule. So we have the base, which is composed of a base and a power raised to another power. So we call this power rule. So a to the m to the n equals the product of the two powers or exponents. So we have a to the mn. Okay. So let's apply power rule in each of the following examples here. So we have 2 to the second to the fourth equals 2 to the second times to the fourth. So this is 2 to the 8. So 2 to the 8 equals 256. Now here, when expanded, the left side equals 3 squared cube times a cube cube. So we have 3 to the second times to the third, a to the third times to the third. So what is 3 to the 6? So we have 729 a to the ninth. So in the third example, so this is equal to 2 cube to the third, x squared to the third, and then y to the fourth to the third. So this is 2 to the ninth, x to the sixth, and y to the 12. So what we did on the two powers of each factor here is to multiply. So we have 3 times 3 equals 9 here, 2 times 3 equals 6, and 4 times 3 equals 12. So we have 2 to the ninth equals 512, x to the 6, and y to the 12. There. Now, class, the third rule is fraction rule. So very obviously, we have the base, which is a fraction, and this is about to be raised to a power. Let's say the power of m. So quantity a all over b to the m power equals a to the m all over b to the m. So we distributed the exponent to both the numerator and the denominator. So we're going to apply fraction rule in each of these examples. So we have quantity 2a cube all over quantity 3b cube. So we have 2 cube a cube all over 3 cube b cube. So we have 2 cube is 8 a cube all over 27 b cube. So for the second example, we have quantity 3xy squared all over quantity 4z squared. So we have 3 squared, x squared, y squared. And then we have 4 squared, z squared. So we have 9 x squared, y squared all over 16 z squared. Now, for this one, this is like 5 to the third. Take note that we have exponent 1 for 5 here. So this is 5 to the first to the third. So this is like 5 to the third. And 5 to the third equals 1 to 5. And then we have x squared cube. So this is x to the 6 all over 2 cube is 8. And then y cube is y cube here. The next rule or law is zero exponent. Now, in here, n expression raised to the zero class equals 1. And we limit a equal to not equal to 0. Okay? So otherwise, that will be undefined. So for example, 3 to the 0 power equals 1. Quantity xy to the 0 power equals 1. Quantity 2xy all over 11z to the 0 equals 1. Okay? So again, when any expression is raised to the 0 power except a equals 0, then it must be 1. Now, under the quotient rule class, we have a to the m divided by a to the n. So this horizontal bar denotes division, and we are trying to divide the same base. So what are we going to do? First, if m is greater than n, or if the exponent of the numerator equals the exponent of the denominator, what we will do is copy the same base and then perform subtraction between m and n there. Now, in the event that we have the same base, we have the same exponent, the answer equals 1. If again, m equals n. And the third sub rule here is that whenever the exponent of the denominator is greater than the exponent of the numerator, or if m is less than n, then we will get the reciprocal of the same base, a, for instance here, and then we'll get the difference between n and m. So let's apply these examples. Let's work on these examples applying quotient rule. Now, for the first example here, since I told you that the horizontal bar denotes division, so this is like dividing 25 by 5, and then we have m to the 10th all over m squared. So we'll perform division here. So 25 divided by 5 is 5. And then since m is greater than n, since 10 is greater than 2, so we will copy the base m and then subtract 10 to 2. So we have 8. So this is the answer. Now, in the second example, the base of the numerator and the denominator are the same, and they have the same exponent, m equals n. So this must be equal to 1. So why we come up with 1 here? So everything is canceled. So if we're going to consider the first sub rule under the quotient rule and we copy the same base x, and then we less the exponent, we get the difference between the two exponent, and this will lead us to 0. And we know that any expression raised to the 0 power equals 1. So that's why whenever we have the same base and the same exponent, the answer will always be equal to 1. Okay, for the second example here, we have the same base y and the same exponent, but we have to perform the operation between their coefficients. So this would mean cancelled. So this is 1. And 65 divided by 5 is 13. So the answer here is 13. So here, this is the combination of the three sub rules. But before we proceed with this, let's simplify this one. Obviously, m is less than n here, so we're going to consider the third sub rule. So we will get the reciprocal of the common base z, and that's 1 all over z. And then we'll perform subtraction between n and m. So this is 7 minus 3. So this is 1 all over z to the fourth. Now, for the last example here, so what we will do is just subtract the two exponents and place the difference place the difference. For example, 4 minus 3 is 1. Since 4 is greater than 1, we will cancel this 1 and cancel 4. So this would mean that the difference 1 is placed on the denominator. So a to the fourth, a cubed divided by a to the fourth is equal to 1 all over a, because this is cancelled. So this would mean 1. And then for b squared and b squared, since their exponents are the same, so we will cancel them. So cancel and division would mean a value of 1. Now c to the fourth, c squared. So 4 less 2 is 2. We will place 2 on the numerator side and we will cancel this one since 4 is greater than 2. So we have d to the 10th divided by d cubed. So 10 less 3 is 7. We will place 7 here and cancel d cubed. Now e and e will be cancelled. F cubed all over f squared. So 3 minus 2 is 1. So this will be cancelled and this will be cancelled. So that would mean that the exponent is 1. Now g to the 8 all over g to the 5th. So 8 minus 5 is 3. So we'll cancel this and change to 3. And then copy the remaining expression. So we have c squared d to the 7th f g cubed all over 1, or we have a here. So this is the final answer. So we will just copy the remaining expression, and that's how we simplify the answer. And lastly, we have negative exponent. So how do we manage negative exponent? So for instance, a raised to the negative m power equals 1 all over a to the m. So the negative exponent becomes positive as we get the reciprocal of the base. So since this is a, the reciprocal is 1 all over a. And then right away, the exponent will be changed to positive. So in the first example, x to the negative 2. So the reciprocal of x is 1 all over x. So we have 1 all over x squared. Okay. So A, B, C have negative exponents. So we will get the reciprocal. This is actually 9 times 1 all over A squared times 1 all over B cubed times 1 all over C. And this is equal to 9 all over A squared B cubed C. So for the last example, what we will just do is to transfer an expression with negative exponent on the other place. Like if it's situated on the numerator, it has to be transferred on the denominator and vice versa. So for example, A and B will be transferred on the denominator while C and D will be placed on the numerator. So rewriting them will lead us to the simplified answer of the third example. So we have 3. So we'll place C on the numerator and we'll change the exponent to positive 4 as well as D exponent to positive 5 all over A cubed B squared. So that's it. So I hope you were able to understand simplifying expression using the law of exponent. And that's it for now.